welcome back. So now let's find the last three derivatives. So we want to find the derivative of arcsecant. Right? So arcsecant, of course, is the inverse of secant. So if y equals secant x, we could represent the inverse as arcsecant, or we could switch the x and y. And the inverse would be x equals secant y. And since we know the derivatives of x, secant, and y, we're going to use that equation. Right, so we're going to take the derivative of x equals secant y and solve for dy dx. So we have take the derivative of x with respect to x and the derivative of secant y. Derivative of x with respect to x, of course, is 1. Derivative of secant y, we would have the derivative of secant block times the derivative of the y. So that would be secant y tangent y, and then take the derivative of y with respect to x. So that would be 1 equals secant y tangent y dy dx. And we want to solve for dy dx, so of course we would divide both sides by secant y tangent y. And now we see we have a problem. We have y's in our equation, and we need our equations in terms of x's. Right? Now we can't just use a Pythagorean identity to get rid of a secant or a tangent, because we could get rid of one, but we couldn't get rid of both. So let's try to get rid of, instead, the real problem, which is the y's. All right? All right, so let's think here for a moment. Well, do we have an equation somewhere on this page where we've identified what y is? This one is going to be very helpful. Now we could try y equals secant x, but we would run into a problem. So instead of running into a problem and then having to switch and try y equals arcsecant x, let's just try y equals arcsecant x right from the beginning. All right, so now since y equals arcsecant x, anywhere I have a y, I could replace it with an arcsecant x. So now we have, so we're just going to look at that secant y, tangent y part. So now I have secant, arc, I'm going to put this in parentheses, arcsecant x, tangent, arcsecant x. So we're taking the secant of arcsecant, and we're taking the tangent of arcsecant. Well, secant and arcsecant are inverses of one another, and they undo each other, and so that is x. Right? That's what we do when we take, the arcsecant of both sides, right? If we have secant x, well, we could do it the other way. We could take the secant of both sides if we have arcsecant x. All right, so now let's deal with the tangent of arcsecant. Well, let's step back a moment. Let's just look at this part of that expression. All right, so let's just look at the arcsecant of x. What's that telling us? What do we take the arcsecant of? We take the arcsecant of a ratio. And what does it give us? It gives us an angle measure. So that must mean that arcsecant x is an angle. Well, just very handy there. I have a triangle down there. How about this angle right here? So this angle is going to be arcsecant x, because arcsecant x is just an angle. And that's just a model. I could represent any angle I want, but other than the right angle, of course. But I like that one. That one looks good. All right, so x is a ratio. Well, what is secant? Well, secant is it's a reciprocal of cosine, right? So secant is the hypotenuse over the adjacent. Actually, let me not use secant x, because we've got an x already. So let's just do secant whatever. The secant of anything is the hypotenuse over the adjacent. So I have a ratio because we take the arcsecant of a ratio. I have a ratio that's x. Well, that must mean that x is the hypotenuse and 1 is the adjacent. So now, not only do we have an angle in this triangle, we have two sides. The hypotenuse is x, the adjacent is 1. Well, how do we find that opposite side? Well, we could use Pythagorean theorem, couldn't we? So 1 squared, we'll just call it question mark squared. Question mark. So 1 squared plus question mark squared equals x squared. 1 squared, that's 1. So 1 plus question mark squared is x squared. We're solving for question mark, so let's subtract 1 from both sides. So question mark squared is x squared minus 1. And then we don't want question mark squared, we want just question mark. So we'll take the square root of both sides. So question mark here is x minus 1. That is the adjacent, that is the opposite side. So this is the opposite side. So now we've used the arcsecant to label our triangle. So now we can step back a moment. So we worked from the inside, we worked with the arcsecant. Now let's deal with the tangent. So we want the tangent of that angle. We want the tangent of arcsecant. Well, what's tangent? Well, tangent is opposite over adjacent. I hope I have enough room in here. I think I can just squeeze it in because I'm almost done. All right, so opposite and adjacent, let's look at our triangle. So the opposite side there is the square root of x minus 1. Oops, we left that off. We left off the little square root sign. And the adjacent is 1. So that's just the square root of x minus 1. And guess what? Now we can make a replacement for our problem secant y and tangent y. All right, so now we know that the secant y is x, and the tangent y is the square root of x minus 1. All right, so if you had any trouble understanding it, back up, kind of watch me again, make sure this makes sense to you. All right, so now we have what dy dx is. I'm going to write in another color because I've got a sea of blue here. So dy dx equals 1 divided by, in the denominator, secant y is x, and this is going to always be positive. So it's going to be the absolute value of x times the square root of x minus 1. And now we have derived the derivative for arcsecant. We did it. So the derivative of arcsecant is 1 over the absolute value of x times the square root of x squared minus 1. That one took us a little longer, but I don't think this one will take us as long. You've seen 1. Now it's arccosecant's turn. Finding the derivative of arccosecant. So we know arccosecant is the inverse of cosecant. So if y equals cosecant x, the inverse would be arccosecant x. Or we could just switch the x and the y, and x equals cosecant y. Because we can take the derivative of x, and we can take the derivative of cosecant, and we can take the derivative of y, and then we will discover the derivative of arccosecant. All right, so let's take the derivative with respect to x, right, of the x, and we'll take the derivative of the cosecant y. All right, derivative of x with respect to x is 1. Derivative of cosecant y with respect to y is going to be negative cosecant y, cotangent y, and of course the derivative of y, because it's a chain rule, of y with respect to x will be dy dx. I got to make sure I save every space I can because that was a little crowded on the last board. And we want to solve for dy dx, so we're going to have to divide both sides. I'm going to put the negative in the numerator, if you don't mind. So we have negative 1 cosecant y cotangent y equals dy dx. And oh no, we have the same problem. We got y stuck in there, and it's got to be in terms of x, right? This is the derivative with respect to x, and there's no x. There's y's. Right, and that's a problem. So we need to substitute for the y's. All right, so we're going to have to think about this one. All right, so let's see. Do we have something that we could use to replace the y? Oh wait, there's an equation here. Maybe that will help us. All right, so we have y is arc cosecant x. How about we just replace the y's with arc cosecant? It worked in the last example. Maybe it'll work in this one. Let's find out. All right, so now we have cosecant arc cosecant x. Let me just, there we go. Cotangent arc cosecant x. Arc cosecant and cosecant and arc cosecant are inverses. They cancel each other out. That's an x. All right, that's looking good. All right, so now what do we do with cotangent and arc cosecant? Well, let's think back. So what do you take the cotangent of? Of course, you take the cotangent of an angle, right? So cosecant, this is an angle. Our cosecant, x is an angle. All right. Well, what do you take? Let's deal with the arc cosecant part. What do you take the arc cosecant of? You take the arc cosecant of a ratio, and that gives you an angle. So the arc cosecant part is the angle, and we have labeled our triangle such. And the x is the ratio, because you take the arc cosecant of a ratio, right? So what ratio gives me, what angle gives me this ratio, right? That's what we're dealing with when we're dealing with the inverse trigs. So that means, let's think what cosecant is. So cosecant is the reciprocal of sine. So cosecant is the hypotenuse over the opposite. Right, well, we got x as our ratio. That must mean that x is the hypotenuse and 1 is the opposite. So this is 1 and this is x. And how do we find the missing side? Well, if we have two sides of a right triangle, of course, we use Pythagorean theorem. So we have, and we can just call it question mark again. So 1 squared plus question mark squared equals x squared. Right, so we need to solve for question mark squared. So let's subtract 1 from both sides. So we have, and of course 1 squared is 1. So question mark squared is x squared minus 1. And of course we don't want question mark squared, we wanted question mark. And actually, I'm just going to save every little space we can. You know that the square root of question mark squared is question mark. So question mark is the square root of x squared minus 1. All right, so that is our adjacent side. Let's label a triangle. Since I took up just a tad less space. Oh, that's part of an equal sign. That's what that little line is. We can label this question mark is a question no more. It is the square root of x squared minus 1. All right, so we got that part taken care of. We got our triangle labeled. All right, we know what cosecant is, but we want cotangent, right? So where are we going to squeeze it in? Right here maybe. We're taking cotangent, we take the cotangent of an angle. Our angle happens to be cosecant x. But what is cotangent? Cotangent is the adjacent over the opposite. Right, so adjacent, right there, square root of x squared minus 1, opposite. Right there, it's 1. Right, so that would be equal to the square root of x squared minus 1 over 1. But do you really need the over 1? Of course not. So x squared minus 1. So now we can replace the cosecant y, this part here, we can replace that with an x. We can replace the cotangent y, we have taken care of that, with the square root of x squared minus 1. And guess what? We've done it. We did it. We discovered the derivative for our cosecant. The derivative for our cosecant is negative 1 divided by, now the only thing is the x is going to be positive, so take the absolute value of the x. That'll make it positive all the time. The square root of x squared minus 1. Hey, that was the same thing we got for our secant, except for the sign. And that makes a lot of sense, doesn't it? Because secant and cosecant have the same derivative as well, except for the sign. Well, sort of. Well, no, maybe not exactly. But their only difference is the sign. So, remember, the derivative of secant was secant tangent, and the derivative of cosecant is cosecant cotangent. So they're kind of alike. So they use those themselves, and they use the reciprocals of one another. So it kind of makes sense that maybe they'd be the same, only the sign. And again, if this didn't, hopefully that made good sense to you. You can always watch me again, slow it down, watch it one more time. All right? But I think once you've seen cosecant derived, once you've seen arcsecant derived, watching arc cosecant wasn't too much different. So the derivative of arc cosecant x is negative 1 divided by the absolute value of x times the square root of x squared minus 1. There it is. We have 1 left. The derivative of cotangent, and actually this one's pretty easy. I don't need any triangles. As you see, there's no triangles, because I'm not going to be stuck with two trig functions in the same equation. All right, so we want to find the derivative of arc cotangent. Arc cotangent is the inverse of cotangent. We can also find the inverse by switching x and y. So if y equals cotangent x, then the inverse is x equals cotangent y. Solve for dy dx. So we want to take the derivative with respect to x of x equals cotangent y. Derivative of x with respect to x is 1. Derivative of cotangent y with respect to x, derivative of cotangent is going to be cosecant squared y. Derivative of y is dy dx. For solving for dy dx, we better divide both sides by, oops, listen to me 1 second. The derivative of cotangent is negative cosecant squared y. Can't forget the negative there. So if we're solving, I'm going to put the negative on the negative 1. If we're solving for dy dx, let's divide both sides by cosecant squared y. Oh no, we're stuck with a y. That's no good. Can't have a y. It's with respect to x. It's got to have only x's. What can we do? Well, I don't have a nice little handy replacement like we did on the last two. And you know, when I don't know what to do, I have one equation. Pythagorean theorem. Sine squared y plus cosine squared y equals 1. Well, I don't have any cosecants in there. I have sines and cosines. But I know cosecant is the reciprocal of sine. So cosecant would be the same as 1 over sine. So let's divide everybody by sine squared y. My one equation has helped us with 4 different problems. It's been very helpful. All right, so of course anything divided by itself is 1. Cosine over sine, that's cotangent. And 1 over sine squared, that's going to be cosecant squared y. And now I have a way to replace cosecant. I can replace it with a 1 plus cotangent squared y. And you may be thinking, oh, actually, we have to take, you might be thinking, oh no, that's even worse, right? We're almost done, right? We're still stuck with the y, but not for long, because I know that x is cotangent y. Well, if x is cotangent y, it stands to reason that cotangent y is x, and cotangent squared y is x squared. We can replace that cotangent squared y with the x. We have 1 plus x squared equals cosecant squared y. And guess what? We're not stuck with that cosecant y anymore because we're going to replace it with a 1 plus x squared. That means that dy dx is equal to negative 1 divided by 1 plus x squared. And you know that looked an awful lot like tangent, except for the sign. So the derivative of arc cotangent is exactly like the derivative of tangent, except for the sign. And of course, 1 plus x squared plus 1 doesn't make a difference which way you add. We have found the derivative for arc cotangent, and that is equal to negative 1 over 1 plus x squared. And that's it. We have found the derivatives for all 6, so that when you see, I think it's on the next slide, yeah. So that when you see this chart, it's not just a bunch of expressions and you're like, okay, well, where'd they get these from? I don't know. Right? Now we have derived every one, and now you have discovered how they were solved. So mathematicians, a couple hundred years ago, solved them just the way I just did, right? To discover the formulas for the inverse trig functions. Now, sometimes we're not just going to have an x, right? So if we don't just have an x, of course, we're going to have to take the derivative of whatever we're taking the inverse trig of, right? So if that's not just an x, then we're going to have a du dx, right? And we use the chain rule if u just isn't an x, right? But we will talk about that in the next podcast. Thanks for watching this derivation of the 6 inverse trig functions, the derivatives of the 6 inverse trig functions. Thanks for watching. Bye for now.